presenting. I'm not able to multitask that effectively.
I must say that I've noticed that some people have been writing questions into the chat. I'm sorry, but I'll have to ask you to put them back into the Q&A box, otherwise I'll get completely confused. So we'll start with a question here from Richard Butler. And it says, it looks like you're targeting 10 times A350 rate. Do you think those rates are achievable? Are they unchanged in a post-COVID world? What is the number one bottleneck?
So I guess the first part of that question is about Airbus product policy and so on. So there's probably a limited answer I can give you there. But certainly, of course, we know today, if you just think about the current A320 family compared with the current A350 family, then single aisle production rates are always far higher than long range production rates in terms of aircraft deliveries, and that's just true of the whole industry, not just Airbus. So in terms of the market and in terms of the impact of COVID on the market, clearly it's obvious to everyone that there's an impact today on aviation, a huge impact on aviation today, and we can all see that. We're all living through it, aren't we? But the market we fully expect to recover. Clearly, vaccination and so on is a huge enabler to that. It's a huge enabler to everyone being able to travel again, and then for the market to recover. So there is a focus for the market to recover back to the pre-COVID levels, and then to start growing again as it always has before. And therefore, we're planning for that future, and we're making sure we're prepared for that future whenever it comes.
Okay, thank you. The next question comes from someone called Yang Chen, and it says, thanks for your very interesting presentation. What are the technologies used for joining the different composites and aluminium parts? Any particular challenges in those joining technologies?
Okay, so when we come to assembly, where we're joining together maybe the composite cover with an adjacent metallic component, so the sorts of technologies we're working on there we are looking at some different fastener technologies, particularly to enable the different build philosophy that I talked about right at the beginning of the presentation. We're looking to avoid needing to work inside the tank, which does potentially mean we need different solutions for fasteners to enable that. So those are the sorts of challenges that we're working on within Wing of Tomorrow. So if you like, evolutions to fastener technologies in order to enable a different approach to assembly. That sounds like quite a small and insignificant topic, but actually some of those technology bricks are very important enablers to the overall build philosophy going forward. So they are important.
Okay, thank you. I have a question here from someone called Claudia Bari. It says, thanks, Sue, for your great presentation. In one of your slides shows morphing wings technology, which provides some up to 10% reduction in drag. But wings are still heavy. The Airbus vision to electrify all fleet by 2035 using a hydrogen jet engine combustion or even hydrogen fuel cells. Did you agree that Wing of Tomorrow are still heavy for Airbus Vision 2035? Also, are you aware that your competitor are working on completely different concepts? That needs editing, but I'm afraid you have to do that the best you can.
Okay. So are the wings still too heavy? I mean, it comes back to trade-offs. In any product design, we're always trading all of the different aspects that influence the performance of the aircraft. And I tried to explain that at the beginning, that aircraft performance is one thing, but so is cost, so is sustainability, and so on. For sure, the reason for moving from a metallic wing to a composite wing, which is basic physics that you all understand, is because composites gives us a significant weight benefit. So that's the driver for moving to a composite wing. So I guess that's the main answer to your weight question. In terms of moving towards hydrogen technologies and everything, so Airbus has publicised its vision for how we're working towards zero emissions in the future. What I can say from a Wing of Tomorrow perspective is that any future product that we launch will need a high rate and low cost capability to make its wings, and therefore Wing of Tomorrow is important to underpin any future product that we may choose to launch, whether that be a conventional aeroplane that maybe flies on SAF, or whether it be a full hydrogen aircraft, or anything in between. So we remain focused on our objectives because they're important in any of those product scenarios. And that's probably the best answer I can give to that quite complex question.
Yes, I'm afraid there were a few parts in there.
There were.
Simpler question now. Says,
Okay.
What kind of welding technique do you use during automation?
What kind of welding technique? I don't think I talked about anything today that involved welding in any of the steps. I mean, clearly we are working on other technologies, including things like thermoplastics and so on, where that might be a more relevant question, but it's not something that we're working on in detail within Wing of Tomorrow in particular.
Okay, so from the composite side, not that really happening. Okay, so I have a question.
It's certainly not a focus of Wing of Tomorrow, I would say, because it's not, that wouldn't be quite so relevant from a wing perspective.
Okay, so question here from Stephen Beecher. Says, hi, it's a very informative presentation, thank you. If you're using a controlled automated process for manufacture, the consistency and repeatability between panels should be better than if hand laid. Therefore, to reduce NDT time, could a method using acoustic response be adopted to identify any discrepancies or possible use of accelerometers in set locations? Then if outside the set tolerance, a further C-scan approach adopted.
Okay, so I'm not going to pretend that I'm an NDT expert, so I can't answer the detail in your question around acoustic versus C-scan, first of all. But what I would agree with is that by automating the process, one of the benefits we're looking to try to understand is, does that repeatability mean that we can reduce the amount of inspection by actually knowing that the process has made the component correctly every time? So that is definitely an activity we are looking at, and that's about understanding that those different process parameters and using digitalization to really do that process verification type activity. Okay,
I have a couple of questions here which are actually similar, so I'm going to roll them into one.
Okay.
It is part of your sustainability journey. You mentioned using biosourced materials. Have you already obtained some results of these materials in terms of your performance requirements? And how can a UK-based hub partner who's developing and manufacturing advanced bio-based resins engage with Airbus to support you?
Okay, so technologies like those biotechnologies are not so much part of the Wing of Tomorrow programme, but they are definitely part of our emerging technologies activity within Airbus. So we do have some activity running on that. I don't know the results in detail, I'm afraid, myself. So there would be the potential to engage in that. I wonder if there's a very specific question like that, whether if you wanted to send me your contact details, I could put you in touch with the right person, would probably be the simplest answer to your question.
Yeah, I have a sort of a generalised question, actually, that I'd like to ask from my own perspective, which is, how far down the Airbus supply chain does the Wing of Tomorrow programme penetrate?
So that's interesting. If you look at the different suppliers we have engaged on the project as partners, really it actually crosses quite a wide cross section of that supply chain. We have some of our big traditional tier one suppliers, as you would obviously imagine, like GKN, like Spirit and so on. But we also have partners, down at the level of sealants, fasteners, materials, etc. So it is quite a wide cross section. As I said, nearly 40 partners are involved under collaboration agreements on the programme. And we also have a very, very big network, of course, of the techno centres, catapult centres, and academia involved as well.
Okay, so in a sort of related question to that, how does Airbus support the development of processes that are not currently mature, but potentially offer very significant improvements? You said right at the beginning that you only deal, quite rightly, with mature technologies. But how do we drag the next generation of technologies along?
So as I say, there's a part of Airbus R&T which is more the emerging technologies part, which would look at working with partners on the very low TRL technologies. Wing of Tomorrow is more focused on your kind of TRL3 to TRL6 type development, because that's our job. But there is another part of Airbus R&T that very much focuses on those less mature and more emerging technologies in order to explore the art of the possible and to understand which ones we should then be looking to pick up and move forward because of the benefits they might bring.
Okay, but there is Wing of Tomorrow starts at TRL3, which is in my head quite low rather than mature.
Yes, yeah, we don't start at, yeah, we start in that range, absolutely, yeah. That's right.
That's good. I'm sorry to return back to the questions from the audience. From Usman Shafiq, is any permeability enhancement method being considered to improve production rate?
Permeability enhancement in terms of resin infusion, I guess.
Yeah, the infused.
I guess what we're exploring as part of Wing of Tomorrow is the infusion topic overall, and the trade between the different sort of material layups that we might want to go for from a structural capability point of view, compared with what's the best way to get to use the right materials to enable the component to be made, and obviously to enable it to be made, it needs to be able to be deposited, formed. The previous speaker spoke about forming, and I totally agree with his comment that it's a very important topic, infused and so on. So we've explored a lot of different material formats in the early days of the programme, and looking in detail at things like infusion, permeability, at that level of detail. And then we've selected the materials we're going to use for Wing of Tomorrow, the formats we're going to use, and now we're actually making the full-size components. But certainly we did in the early days of the programme, when we were selecting the basic materials, explore things like that, those topics. Okay,
I think we're going to have to close up in a moment. I mean, we've had your 50 minutes of torture. A couple of last questions before we go. One from Rob Piper, which is, as cost is such an important driver for a successful future product, can you give any indication of how close you are to meeting future cost and rate targets?
Can I give any indication? I mean, I guess we know exactly where we are against the target. We know what the best options look like being from a cost point of view, but of course they might have other disadvantages. I keep talking about trades, because designing an aeroplane is all about trading one aspect against another. We have multiple options still open to us that we're still working on in parallel, and one of the reasons for keeping those options open is so that we do leave ourselves the opportunity to continue to make a choice between cost and performance, for example. So clearly, in a program like this, you do start to converge to what looks like it's going to be the best option in the end, but we're not there yet. We're still working the options, we're still doing those trades, and we're still, of course, always mindful of our targets.
Okay, I think one last question. This will be the absolute last question. 2 or 3 questions just come in from the audience, basically all around the same topic of whether it will be possible to use thermoplastic matrices in future aircraft wings, or whether the thermoset composites will remain dominant?
So we are also exploring thermoplastics within Wing of Tomorrow. So we're working with 3 different partners, for example, on thermoplastic wing box ribs, but we're not looking at thermoplastics for the main wing covers and spars. That's not seen as the way forward at the moment. Okay,
thank you. I think that's the end of the allotted time. So thank you very much for an extremely helpful and insightful look into where Airbus is going with this. Thank you.
Okay, you're very welcome. Thanks.
Okay, Tim?
So I think we're now due a 20-minute break, if everybody wants to take that, or would you like to bring it forward?
I think 20-minute break sounds like quite a good idea to me. So should we reconvene at 4:10?
Yeah, that's fine. If the panelists would just like to stay online rather than logging out,
yeah.
And then I'll just put up a holding screen until we come back at 4:10.
Okay, thank you.